Hi there, my name is James Fraser. I'm a professor in the Department of Physics, Engineering, Physics, and Astronomy. And what I wanted to explore with you today is to have you think about something that maybe you're quite familiar with, but see it from a different perspective. Sometimes when you're able to look at something differently, new opportunities are created. The thing I want you to think about is a beautiful June day. It's a lovely field, and maybe you're out lying in this field, soaking up the sun. Well, you're very familiar with that light power that is coming from the sun and hitting you. But let's think about a specific amount. Let's say you happen to have a hula hoop. How much power is actually in the middle of the day in June going through that hula hoop? Well, it's about 1,000 watts. And you have everyday experience with this. You know what it feels like. Can we look at this light from a different perspective? Can we do something with it that really is not at all obvious? The sort of light that I can create in my lab has a similar amount of power, but it's coming from a laser. And that allows us to use a lens to focus it down very, very tightly, much tighter than you'd ever be able to do with sunlight. I can actually get it down to about 50 microns. So that is about slightly smaller than the diameter of a hair on your head. Because we've reduced the area over which this power is flowing by 4 orders of magnitude, it is much more intense, 100 million times more intense. So we've taken the exact same power, but now instead of being spread out over a hula hoop, it's spread out over the cross section of your hair. As an experimentalist, I like to answer questions using experiments. I'd love to bring you into my laser lab in Stirling Hall. Can't really do that, but we can do, well, the next best thing. Let's just go down into the basement and meet Allison Sibley, who's a graduate student in the team.
Hi, I'm Allison, and I'm going to see what happens when we focus 1,000 watts of light onto a solid piece of steel.
And the laser turns on. Oh, the piece completely dropped out. Interestingly enough, that laser light is still on, but you can't see it. It's actually invisible. We could talk about that.
I guess it went all the way through.
Thank you to Allison for putting together that video. We could talk about where this sorts of experiments could go to, but I'd like you to think about maybe already the fact that we can use laser light to cut and to create things is already impacting you. Maybe you have a smartphone in your pocket, and we could talk about all the different sections and parts of a smartphone and how laser light was used to cut, machine, weld, or process it to make it into such a great gizmo. We could also talk about where this research might go to, but I'd like to think about where it can lead in terms of the people who are actually part of the team and what they're doing now. So looking at some of the former students in the group who were using laser light to study and to control things, you can see that they are spread across North America and doing a variety of interesting careers which are really having impact and helping people. So I hope next time you're lying out in a nice June day that you look at that sunlight from a different perspective and think about how if you could focus it down to 50 microns, you'd be able to cut through steel, which would be pretty fun. How this has already been used in a variety of advanced automotive manufacturing applications, and how these sorts of different perspective can lead to really interesting careers, solving problems that positively impact people. And maybe you one day will be one of these people solving these problems using light. Thank you very much.